Today, we are going to look at an example of application of differentiation. Now, let's take a look at the question. A rectangular plot of farmland will be bounded on one side by a river and on other three sides by a single strand electric fence. With 800 meters of wire at your disposal, what is the largest area you can enclose and what are its dimensions? Okay, so when you get this type of questions, please read the question carefully and then detect what does the question wants. Okay, so here I can see that there's actually two questions. With 800 meters of wire at your disposal, what is the largest area that you can enclose and what are its dimensions? So as you can see, there are two whats here. That means there are two things that we have to answer. The first one is what is the largest area. The second one is the dimension. What does the dimension means? It means the size of the rectangular plot farmland. Okay, so remember the steps that I have mentioned before. The first step to solve this type of question is to determine what is it that we want to solve. Is it to maximize or minimize a function? Okay, so in this question, we can see that the first part of the question mentioned about the largest area that you can enclose, and this simply refers to maximizing the area. Okay, so for this question is to maximize. Next step. The next step that I have mentioned before is to find or to determine what type of function is it that we want to maximize. And for this question, after the word largest, you can see the word, yes, the word area. So this is the function that we want to maximize, which is the area function. Okay, next, the third step would be to differentiate this function and equate it to 0. So what was the function that we want to maximize? Is the area function. So this means we have to differentiate that area function and equate it to 0. And of course, after that, you will find the value of the variable that we are looking for. Okay, and then don't forget the last step or the fourth step is to find the second derivative. Even though this is not needed, but it is actually very, very important because you want to check whether the value that is equal to 0 when you differentiate it is the result of the maximizing the area and not minimizing the area. Okay, so that's why we have to check the second derivative. To solve or to use all of these four steps, the first thing that we need is of course the area function. So what is the area function for this question? Well, of course right now we have no idea what is the area because we have not sketched and we cannot simply just imagine how it looks like. Okay, so just sketch a rectangular plot of farmland. So from here we can see that, oh, it looks like a rectangular. So start with the shape of rectangular. Draw a rectangular. Rectangular has two same sides. And then it's bounded by one side by a river. So let's say this is your river. And then on the other three sides by a single strand electric fence. So that means at the other three sides, there's the electric fence. And then we have 800 meters of wire at your disposal. Of course, that 800 meters of wire is only needed for our three sides here. Another way that we can think of it is that 800 meters is actually the perimeter of this rectangular, but it's not the perimeter of the whole rectangular because one-sided doesn't have the electric fence because this one is open, okay, because it's the river. So we have to let variables at our sketch here. So what are the variables that we can let? So usually when we have a rectangular shape, we will label the width as x and then the length as y, for example. Okay, so if we have x and y as the width and the length of this rectangular, then we can write an equation of this 800 meters, okay, where this x length, of course, is the same as this x length here, and the y length is, of course, only at this side. Okay, so as you can see, to find the perimeter of this rectangular plot of farmland is just 2x plus y. Why is it 2x plus y? Because we have x plus y equal to 800. Okay, and from here you can simplify it to be 2x plus y equal to 800. So from here you get one equation of x and y. Okay, but that does not give us the function that we want to maximize, which is the area function. So now what is the area of a rectangular? How to find the area of a rectangular? It's just x multiplied with y. Now, after that, what do we have to do next? If we have more than one variable here, of course we cannot differentiate dA over d because we don't know whether we have to differentiate with respect to x or with respect to y, because both of them are variables in this question. So this means we have to change one variable. And how are we going to change it? Remember that we have this another equation. So whenever we have more than one variable, usually in the question there will be more than one information that we can use. So that other extra information given is to help us to change the variable to be one variable. Okay, so for this case, it's this equation. So I want to let y as the subject because I see that y is alone. Y is just one y, whereas x is 2x. So it's easier if I just change or let y as the subject. And here, I can replace that y to be 800 minus 2x from that equation. Okay? And then next, what do we do? Of course, we have to expand it. Okay? Now, this is your area function. Once we have the area function with respect to only one variable, then we can differentiate with respect to that variable, which is x. Okay? So, differentiate it as usual and then equate it to 0. So, from here, you can solve the value of x. So, x is equal to 200. And don't forget the unit is in meters. Okay, next, what should we do? Remember, the fourth step is to find the second derivative. So don't forget, go ahead and do your fourth step. So when we differentiate the second derivative, we get negative 4, which is less than 0. And when it's less than 0, remember, it's a negative amount in our bank account. So of course, we are sad. So draw the sad face. And here you see, it's actually maximum. So we can conclude that the maximum area exists. Here it means that the value x equal to 200 meters maximizes the area and does not minimize the area. And it agrees to what we are looking for. So we have found what is the value of x which maximizes the area. But hold on a minute. The question wants us to find what is the largest area and also what are its dimensions. So this x equal to 200 is giving us the dimension. But of course, the dimension doesn't want only just value of x, but also wants the value of y. So we also need to find the value of y, and then what other information does the question wants? It also wants us to find the largest area. So this means we want to state what is the value of area that maximizes the rectangular plot farmland. Okay, so this means we have to find the value of y. So how to find the value of y? Just replacing your x into this y equation. 800 minus 2 times 200 meters. And your answer is 400 meters for your y. Okay, next, to find the largest area means you have to find the value of the area which maximizes. So the area function is 800x minus 2x squared. But we also have another equation for area, which is x times y. So you can use either one. So let's say since we already have the value of x and value of y, I don't want to use this function to find the area, so I just use the function a equal to x times y. So my x would be 200 and then multiply with my y value, which is 400, and then the final answer that I get for my area would be 80,000 meters squared because it's area. And lastly, we can conclude the largest area is 80,000 meters squared with x equal to 200 meters and y equal to 400 meters as the dimensions.